Alright, so this is do now number 3. Number 1a is asking you to evaluate f of x when x is negative 2. That's what f of negative 2 means. So again, wherever you see an x, we replace it with a negative 2 and then simplify after that. So this, remember, order of operations, you do the exponent first, so negative 3 times negative 8. 5 times negative 2 is negative 10 minus 10, so then that gives you 24 minus 20, and that gives you 4. Okay, so letter B is a piecewise function because it's a function that is broken up into more than one piece. In this case, 2 pieces. We have this one and this one. This is the domain. This is what tells us, you know, which part to pick, either the first or the second. So when x is negative 2, I'm looking for which part in which piece do I find negative 2. If I have the domain broken up into 2 sections. So negative 2 would go here, right? Because negative 2 is less than negative 1. So that means that we are going to replace the x with negative 2 in this piece. So we get 4 plus 14, so that's 18. Okay, so remember, for every input in a function, there is exactly one output, not more than one. So for a g of negative 2, the answer is 18, and that's it. For g of negative 1, notice there are 2 negative 1s right here. So the one that contains negative 1 is the first piece, because this one says greater than negative 1, not equal to. This one says equal to. So this is this is where negative 1 belongs, right? And so again, we're going to use that same piece again. So it's going to be 4 minus 7 times negative 1. 4 plus 7 gives you 11. For the third piece, it's g of 0. And so again, you check, where is 0 here? Is 0 less than or equal to negative 1? Nope. Is 0 greater than negative 1? Yes, it belongs right here. So that means we're going to use this piece of the graph. I'm sorry, the function, not the graph. So we have absolute value of 5 times 0 minus 11. And so we get absolute value of negative 11, 0 minus 11, which is 11. And it's okay to get the same y value for different x values. That's fine. Okay? Okay, so here we're not going to evaluate for a value, for a number value. We're going to evaluate the expression for h of t minus 3. So again, just like before, what it means is wherever you see an x, you're going to replace that with the expression t minus 3, okay, with the binomial. So that's the first step. Just replace all your x's with t minus 3, and then we'll simplify. Okay. So order of operations tells you that you do this part first, the exponent, the 2 goes later. So this is t squared. Remember, this is not t squared plus 9. That's a very common mistake. Don't forget the middle term. So it's t squared minus 6t plus 9. And then I'll just bring down and do the distributive property in the next line, like this. So now I'm going to distribute the 2t squared minus 12t plus 18, then distribute the negative 5 minus 5t plus 15, because a negative times a negative here is a positive, plus 8. So common terms, the only t squared is this one, so you just bring it down, 2t squared. Then you have a negative 12t and a negative 5t, that's negative 17t. And then you have the 18 and the 15 and the 8. So you add those together and you get what? 26, 41. Okay, and so h of t minus 3 equals this.